Hello, scholars, Mrs. Majors. Let's go. All right, skill 20, factor and remainder theorem. So we're going to learn two theorems, factor theorem and remainder theorem. And in order for us to learn it, we got to investigate a few things. So if you know that 4 is a factor of 32, what happens when you divide 32 by 4? Well, 32 by 4, 8 of them, 32, whoop. There's my remainder. So we notice that the remainder is 0. Or some of you might say, you know, it evenly divides them, like meaning there's no remainder. Okay? So let's translate that into polynomial. Okay? So if you know that x plus 1 is a factor of that, what do we notice when we divide that by that? Well, I don't know. So let's go ahead and divide it. Notice that we are dividing by the linear divisor. So just like the previous lesson, let's go ahead and use a synthetic division. How does it go? All the coefficient and with no missing terms. So 3, 2, 1, 0. So 3, 2, 1, 0. And you set the divisor equal to 0. X is equal to -1. So -1 goes here. So that's a basic setup. I think Mr. Bayer put the box over there. So let's go. Number drop down. 1 times -1 is -1. And add it. -5. Multiply. 5. Add it. 4. Multiply. Add it. 0. So my remainder is 0. So just like the previous one, when I know that x plus 1 is a factor of that polynomial, when I divide, my remainder is 0 again. So that's good. So that's what we predicted, right? So now, can we factor any further to find out the other roots of a polynomial? If so, write the completely factor polynomial below. So what it's asking is that if I know that x plus 1 is a factor, what are the other factors of this polynomial? That's what it's saying. Okay, so would you guys agree that then over here, when I divide x cubed plus minus 4x squared minus x plus 4 by x plus 1, my answer, the quotient, will be what? X squared minus 5x plus 4. Are you guys good with that? Right? Because that's how you find the quotient when you divide it by the linear. Well, what does that mean? Wouldn't that mean that x cubed minus 4x squared minus x plus 4 will be equal to x plus 1 times x squared minus 5x plus 4? Oops. Right? Well, why does that make sense? Because, alright, give me 1 second. There you go. It makes sense because over here, when I divide 32 by 4, I got 8. Then can I say that 32 is same as 4 times 8? Oh yeah. So same thing. Divisor, quotient. So divisor times quotient equal to the dividend. So divisor times dividend, quotient equal to dividend. So it's asking you, do you know how to factor this? Yes, we know. I'm going to do A, C, B. A times C is 4, B is -5. Find two numbers, add up to be 4, multiply to -5, -4, and -1. Notice the A value is 1, so I can take a shortcut, x minus 4, x minus 1, and keep that first factor in the same. If that factoring looks weird to you, you need to review Algebra 1, factoring polynomial, trinomial. Okay, so there it is. These are all my factor form of this x cubed minus 4x squared minus x plus 4. It says use the same method to divide that by that. Okay, so let's use a synthetic division. So 3, 2, 1, 0. Miss, what are you doing? 3, 2, 1, 0. Like, what are you counting? I'm just counting the coefficient here. So okay, 3, 2, 1, 0. I do that as a habit so that I don't have any missing term to it. Okay, divided by, this time I'm dividing by x minus 3. So set it equal to 0. X is equal to 3. So I put 3 over here. Let's go. Multiply, add, multiply, add, multiply, add. Oop! What happened? My remainder is -8 this time. Okay. Well, that's all it's asking you to do. So let's go. Given that, use your work to identify the x-intercept and all that. Okay. So I'm gonna so that's same as the f of x that we've been using on the top. From number 3, I already factor it. So my factor form was what? x plus 1 times x minus 4 times x minus 1. Right? Well, I need to find x-intercept. How do you find x-intercept? That's same as a 0. So I'm going to set it equal to 0. Then I get x is equal to negative 1. X is equal to 4. X is equal to 1. So those are all the x-intercepts, zeros, roots, all the same thing. Now it's asking me a little different. Find f of negative 1. Okay, how do you find it? You take negative 1, plug it into your x's. That's how you evaluate the function, right? So negative 1 cubed minus 4 times negative 1 squared minus negative 1. Be careful here with the negatives. Plus 4. Negative 1 cubed is negative 1. Over here, do I do exponent first or multiply first? Exponent first, so negative 1 squared is 1. 1 times negative 4 is negative 4. Negative 1 is plus 1, plus 4. Negative 5 plus 5 is 0. Okay, let's keep going. F of 3, same thing. Plug 3 inside of the x. And then notice I put the parentheses around everything to protect it. 3 cubed is 27. Over here, square first. 9 times negative 4 is negative 36. Minus 3 plus 4. Negative 9. Negative 12 plus 4 is negative 8. Okay? Alright. Now, the last part is the hard part. Now, compare these to the remainders from number 2 and number 4. Make a conjecture about how evaluating a function and dividing are connected. Okay, this is the hard task over here. So let's look at it. It says compare these with number 2 and number 4 remainder. All right, let's look at number 2. When you divide by x plus 1, what was our remainder? Remainder was 0. When you did f of negative 1, what did you get? 0. So they're the same thing. Okay. For number 4, look at number 4. I know I keep going back and forth on the pages. When you divide by x minus 3, what was my remainder? I guess I should write it down. Remainder is negative 8. Okay. And when you evaluate f of 3, the same value here as here, what do we get? Negative 8. Oh, so they're the same values. Right? Do you guys see it? Yeah? They're the same thing. So once again, when you divide it by x plus 1, when you divide it by x plus 1, which you get the negative 1 as a possible 0, you get the remainder of 0. Another way of finding that will be do just the f of negative 1, evaluate it. When you divide it by x minus 3, with the possible 0 of 3, my remainder is same as just doing f of 3. So that's what we're going to write it over top there. The remainder theorem and the factor theorem. So what does remainder theorem says? If a polynomial is divided by x minus k, then the remainder is f of k. The remainder is f of k. Let me show you an example. Remember the previous page? Yeah. We divided by x plus 1. And what was the remainder? F of negative 1. Because the k value is negative 1 here. When you divide it by x minus 3, what will be the remainder? F of 3. And we saw it on the previous page. Remember that? Yeah, so that's what the remainder theorem is saying. So if you want to know the remainder when you're dividing a polynomial by something, instead of literally doing the division, you can just evaluate the value by plugging it in to x's instead of doing the division. Sometimes you can do the division and that might be shorter, but a lot of polynomials are very complicated, so this just gives you a shortcut of finding the remainder really fast. We're going to see some example later, okay? So right now I just want you to just get used to it a little bit. I know you're a little confused. Maybe not. All right, factor theorem. What does factor theorem says? If f of k is equal to 0, then kx equal to k is a root 0 of the function. I mean, it kind of relates to the remainder theorem, right? Because when you plug it in, got the 0, that means the remainder is 0. So this means remainder is 0, then it should be the root of 0. Factor. Therefore, x minus k is a factor. So example from above, when we did the f of negative 1 in the previous page, f of negative 1, over here, f of negative 1, we got the 0. Remember that? F of negative 1 was 0, yeah. Then, x is negative 1 is a root. Then, x equal negative 1 is a root. Thus, x plus 1 is a factor. Therefore, x plus 1 is a factor of the f of x. Okay? Alright, so now let's look at the example. If f of x is that, then what is a remainder when f of x is divided by x minus 2? Alright, so here's the thing. Yes, you can do the synthetic division. So you can literally divide that by that to find the remainder. That's fine. But since we know the remainder theorem, the remainder is same as what? X is equal to 0, x is equal to 2, f of 2. Right? So instead of doing the synthetic division, I can just do f of 2. Let's go. 3 times 2 cubed to the 5th power plus 4 is, that's a big number, 68, 96 plus 4, 100. So what's the remainder? 100. I'm done. Right? That took a lot shorter time. Ms. Major, I don't trust you. Fine, I will show you. Let's actually do the dividing and then check it or prove it. Okay? So I'm doing the synthetic division. So 3, 5, 4, 3, 2, 1, 0. I'm just counting down because there are lots of missing terms. So you need to put the zeros under all the missing terms. Divided by what? 2. I mean, so as you can see, yes, you can do it, but we are wasting lots of my time and your time, and I'm trying not to get confused. There you go. So my remainder is 100. So there you go. Okay? All right, let's go next. If f of x is that, and the remainder when divided by x plus 2 is negative 18, then what is the value of k? Okay, so I'm going to use the remainder theorem. So according to remainder theorem, which is over here, when you divide the remainder same as the f of x, I can say that x is equal to negative 2. F of negative 2 is equal to negative 18. Right? Because the remainder is same as the f of that value that you're dividing by. So that's what I'm going to do. F of negative 2 is equal to 2, negative 2 cubed plus k, negative 2 minus 4. Negative 8 times 2 is negative 16 minus 2k minus 4 is equal to 18, equal to 18. Negative 20 minus 2k equal to 18. Negative 2k is equal to 38. K is equal to negative 19. Negative 19. Cool? Alright, well, I don't trust you, okay? Fine, you guys have trust issue. That's fine. You can actually do it using the synthetic division if you want to. So let's go. 3, 2, 1. Obviously, on the quiz, you don't have to do this. At equal to 0, negative 2. But you can. No problem. K plus 8. And I think this is how you guys did it in Algebra 2. See, it kind of gets complicated. So negative 4 minus 2k minus 16 is your remainder. And it says the remainder is 18. So you're going to set that equal to 18, which you get k equal to negative 19. Cool? So why did we do it like this in Algebra 2, but now we're doing a new way? Because remainder theorem makes it shorter. A lot simpler. Okay? Alright. 2 more questions. Given that a and x minus 1 is a factor, okay, then what is that? Well, since x minus 1 is a factor, do you guys agree that the this will divide f of x evenly. Yeah. Once again, since it's a factor, it's going to divide evenly. Yeah. Do you agree that that means remainder is 0? Yeah. Okay. So divides. I'm going to write it down. Evenly. Well, that means remainder is 0. Yeah. Well, would you guys agree that that means then f of whatever that is going to be equal to 0? Yeah. So this is the factor theorem over here. That's a remainder theorem right there. And what would that go? What will go over here? Well, we are making x minus 1 as a factor. So if we were to set it equal to 0, it will be f of 1 will be equal to 0. So f of 1, 3, just plug it in. 1 plus 1, 3 plus k plus 1 equal to 0. 4 plus k is equal to 0. K is equal to negative 4. K is equal to negative 4. So that's how you do it. Since x minus 1 is a factor, set that equal to 0, so f of 1 should be equal to 0 according to the factor theorem. So that's what I did. Once again, if you want to divide, that's fine. That's fine. 3, 2, 0. Oh, my pen. 3, 2, 0. No, I can't count. 3, 2, 1, 0. Oof. Divided by 1. This is just a checking. K plus 1, k plus 1, k plus 2. What did I do? Oh, k plus 3 here. K plus 3, k plus 4 equal to 0. K is equal to negative 4. So either way. Okay, this is check again. Last but not least. If that's a factor, how do we know? Well, if it's a factor, then f of negative 2 should be equal to 0, right? But the remainder should be 0. So, let's plug it in. If it's a factor, the remainder should be 0. So according to the remainder theorem, I just plug it in to make the remainder equal to 0. Negative 8 plus 32 plus 4 plus 3. I get 31. So nope. Nope. Well, if you wanted to do it, yes, you could have divided. Yada, yada, yada. So since remainder is not 0, nope. Cool. Okay, so that is the lesson of the factor theorem and remainder theorem. Thank you.